In water supply engineering, Unit 4, Advanced Water Treatment. In last unit, we see about basically treatment process. What are the treatment process in treatment unit, basic treatment unit. In this unit, we see about advanced water treatment plant. The general treatment process given to the water like coagulation, sedimentation, filtration, and chlorination are used to remove solid particles, and the water collected from the sedimentation and filtration unit may contain some dissolved salts, minerals, particles. In some special and advanced treatment methods are essentially required to remove the unwanted minerals or to change the color, taste, and odor of the water. For example, gases like carbon dioxide, hydrogen sulfide may present in water, create some odor and import taste because of its origin or contaminated on its way. In order to remove these unwanted minerals or gases, miscellaneous water treatments have to be adopted. These are all the some advanced water treatment in process. Aeration. Aeration is to remove carbon dioxide gas and H2S gas to kill bacteria and to remove iron and manganese process. Next process, activated carbon treatment. Activated carbon treatment is used to remove unwanted taste, color, and odor. Treatment with CuSO4 is also removed some color, taste, and odor. Oxidation process, it also used to remove color, taste, and odor. Addition of phosphate after oxidation and filtration. In this method, we use to remove iron and manganese. Fluoridization process, we remove the fluoride particles in water. Water softening method, we use to remove oddness of water. Then desalination process is used to remove some salt content. And membrane process is used to remove some dissolved salts. And also it's like a desalination process. Next, objectives of advanced water treatment plant. Here, to remove unwanted minerals, taste, odor, and color. Some unwanted minerals means iron, manganese, and fluoride. And unwanted gases also removed in this type. That means carbon dioxide, hydrogen sulfide. These types of gas also removed from this advanced water treatment process to remove the fluoride contents and to remove the permanent and temporary oddness and also kill the bacteria. Finally, remove the possible salts and to reduce the salt content of water. Next, excessive manganese content. Manganese levels over 0.5 milligram per liter lead to black to brown discoloration and import a little metallic taste of water. Heavier exposure over a period of years has been associated with nervous system toxicity characteristic by abnormal movements. Excessive fluoride content. In excessive fluoride content, it remove it creates some dangerous effects like neurosystem affected and affects the brain and causes cancer, changes lung structure and strength, cause birth defect and parental death, impairs immune system, causes initial stages of skeletal fluorosis and osteoarthritis. Similarly, dissolved gases like carbon dioxide, hydrogen sulfide for bad odor and make the water as corrosive agent. Aeration process is the first steps to remove the taste, color, and water. Aeration Generally, the surface water, like river water or stream water, are free from the pollution by dissolved gases. Since the surface water is open to the environment, which has high content of oxygen content, act as a cleansing agent to the water in open source. But in case of groundwater, the chances of getting pollutes high, and this happens by the infiltration of groundwater. When the water infiltrates the ground, it often carries organic matter which decays and generate carbon dioxide and hydrogen sulfate gas. Thereby, the water get polluted. Following are the various treatments generally adopted to overcome the problems association with dissolved gases and unwanted minerals, like aeration, treatment with activated carbon, treatment with copper sulfate, oxidation of organic matter. Aeration process. Aeration is defined as the physical process in which the water is made to contact with air in order to absorb oxygen and to remove carbon dioxide gas. This process also kills the bacteria and remove hydrogen sulfate gas, iron and manganese to some extent. There are two types of aeration process. One is introduction of water into the air and introduction of air into the water. And the method of aeration of water can be carried out the following ways: by using spray nozzles, by permitting water to trickle over gasket method, by air diffusion method, and by using trickling bed method. By using spray nozzles method, this method will aerate the water by sprinkling the water in air. Water is sprinkled in air or atmospheric pressure through special nozzles which breaks the water into droplets, thus permitting the escape of dissolved gases. The sprinkled water travels about 2 to 2.5 meter high under water pressure of 0.76 to 1.5 1.5 1.15 kg per centimeter square. Research shows that this method of aeration will remove 70 to 90 percentage of carbon dioxide, and it also kills the bacteria in the water. The nozzle opening should be large more than 2 centimeters to avoid clogging. But at the same time, the construction should be such that the water is dispersed into fine droplets. Typical design values for aeration. Design parameters: pressure range 0.7 to 1.5 kg per centimeter square, and nozzle diameter 2.5 to 3.8 centimeter. Discharge rate 4.7 to 6.5 liters per second, and nozzle spacing 0.6 to 3.7 meter. Area required 4.75 to 14.2 meters square. This is the spray nozzles. By permitting water to trickle over gaskets, it is here. In this method, the water is allowed to fall the height of about 1 meter to 3 meter over a step in series, with a fall of about 0.15 meter to 0.3 meter in each step. This arrangement is called free fall aerator, and its typical type is called cascade aerator. The water flow over through a series of steps like arrangement from which the water gets good contact with oxygen in air, which influence in removing the dissolved gases. But this method is less efficiency when compared to other methods. The removal of efficiency of carbon dioxide in this system that ranges between 50 to 65 percentage only. Area required 0.9 to 1.2 meters square per milliliter per day of capacity. Total height is 1 to 4 meter. The structures were formed is known as freefall aerator. The simplest type of freefall aerator is called as gasket aerator. This is the gasket aerator diagram. Next, by air diffusion method. In this method, compressed air is bubbled through the water so as to thoroughly mix it with water. Perforated pipes are installed at the bottom of the settling tanks and the compressed air is blown through them. The air bubbles while coming up from the bottom of tank and aeration of water is thus achieved. The depth of aeration tanks is generally kept as to about 2.5 to 3 meter. They work on the principle of continuous flow with minimum detention period of 15 minutes. The removal of efficiency of the diffused aeration can be improved by the following methods. By increasing the bubble size and by increasing the detention time, by increasing the water depth and increasing the volumetric air to the water ratio. In diffused air method, the tank depth 2.7 meter to 4.6 meter and length of the tank is 3 meter to 9.1 meter and length to breadth ratio for effective mixing is 2 meter. 2 length to breadth ratio is 2. Detention time we produce 10 to 30 minutes. Air required 75 to 112 meter cube per milliliter of water. Power required 0.13 to 0.52 kilowatt per million of day. Air diffusion aerator, that is multiple try aeration method. Next method by using trickling bed. In this method, the water is allowed to trickle down of beds of coke supported over perforated trays and arranged vertically in series. 3 beds are used, the depth of each being about 0.6 meter. The water is applied from the top through perforated distribution pipes and allowed to trickle down up to the bottom bed. This is the trickling filter bed. Next method is iron and manganese removal method. Iron and manganese minerals are found in soil and rock. Iron and manganese can dissolve into groundwater as it is percolates through the soil and rock. Iron in the ferrous form and the manganese in the form of objectionable. More than 0.3 milligram per liter of iron will cause yellow to reddish brown stains of plumbing fixtures or almost anything that it contacts. If the concentration exceeds 1 milligram per liter, the taste of water will be metallic and the water may be turbid. Manganese, even at levels as low as 0.1 milligram per liter, will cause blackish staining of fixtures and anything else it contacts. If the water contains both iron and manganese, staining could vary from dark brown to black. Consumer complaints or laundry is stained and that the water is red or dirty. Iron and manganese should not be aerated unless filtration is provided. Defluoridization. Adjustment of level of fluoride in drinking water to the optimum level is called as defluoridization. Presence of some quantity of fluoride is necessary in water. In certain terrain, the groundwater contains less fluoride because of the soil mineralogy, which cause adverse effect to teeth acid for fever cavities in teeth of children. The process of adding fluoride solution in the water to increase the fluoride content, water is called as fluoridization. Fluoridization techniques may be classified into four categories. That is absorption technique, ion change technique, precipitation technique, other techniques. This is the fluoride contaminated water. Defluoridization due to rapid urbanization and growth of modern industries, fluoride concentration level increases in the environment. The high concentration of fluoride will have adverse health effects as discussed early in this chapter. The discuss of removing the excess fluoridization from water is known as defluoridization. This is the one of the method of Nalgonda technique process to remove the fluoridization from water. This is one of the oldest technique which was initially adopted in the village of Nalgonda in India. It works on the principle of flocculation. Initially, the raw water mixed with lime or sodium carbonate in order to start the process of alkaline condition for effective hydrolysis of alum salts. This is the Nalgona techniques diagram. Remove efficient fluorides from 1.5 to 20 milligram per liter is desirable levels. Simultaneous removal of color, turbidity, bacteria, and other organic contaminations. Applicable in batch as well as in continuous operations to suit needs. Needs minimum of mechanical and electrical equipments. Adaptable of domestic use. Demineralization. Demineralized water is specially purified water that has had most or all of its mineral and salt ions as removed. Next, demineralized water. That is no reduction when operating on diesel fuel, purging after firing on diesel fuel, gas turbine compressor, closed cooling system make up water. Next process is water softening. In next class, we see this water softening process. Thank you.